Welcome everybody. It is me. It is the Cyber Warrior. This is Cyber Warrior Studios, and it is Tech Tuesday. And if you haven't been keeping up, this is a video that is in a series of videos for Tech Tuesday. Also my Linux playlist that is all about Linux basics for hackers. So we are going to discuss some things today that are in that book, since we're on, going through it, as well as just kind of some of the concepts they talk about. And today is all about process management, and it is of vital importance to hackers and Linux administrators and just overall users of any operating system. We're handling this from the Linux front, but a lot of this information can go into Windows as well, or Mac, or whatever you're using, because processes run everything on your system. So without further ado, let's get into the Linux side of things, because that's how we do here. So as you can see, we're already logged into our Kali box. Again, this is taken from that Linux Basics for Hackers book, and this is the operating system they use. Even along the way, I've made some changes just because we are further ahead in our operating system time than when the book was made, so some changes have taken effect. But I digress. What is a process? Well, a process is any command, program, or anything else that is running on your system. So it could be a system service, it could be anything. So if it's taking up resources, it's a process, especially in Linux. So while we're looking at that, and as we consider how we're going to go about things, let's take a look at the first command, which is PS. So PS is going to show us all the processes that are currently running under our user in this terminal session. So we are currently running sudo, su, zshell, and because we issued the PS command, we are now running the PS command, all right? But what if we wanted to see all processes running on our system by all users? Well, that's when you get into PSAUX. PSAUX is actually, or PSAUX as I like to call it, is going to show you all processes in just a hell of a lot more detail. But all processes by all users, including system users, as well as the command time, when it was started, the CPU percentage, the memory percentage, shows you all this information. So if we really want to look into it, they're all labeled right up here. So user is root for, let's say, this init splash command, all right, or process. And then the PID, the process ID, is 1. And keep in mind, your process ID is very important because that is what you will use to kill or manipulate processes down the line. So knowing how to find your process ID and things of that nature is of vital importance when it comes to this. And then you have the percentage of CPU that's being used by that process, and the percentage of memory, and then of course the command. So if we look down here, if we go down, we see all this stuff that starts on boot, VMware, and things of that nature. And again, because they're like kernel or system services, that's why we don't see it when we just run PS. We only see the commands that we're issuing at that time in that terminal session. But if we look at this, because I have another terminal open here as Kali root, then we have sudo su here, sudo su here, we have a switch user here, and zshell here. All right. So that will allow us to take a look at all these different things. And we also have a few other sudo sus. So I've kind of been doing a few different things, and I'm probably logged into root and out of root and into root and out of root and into root a few different times. So understand that there's a reason behind all these, and you can kill them all. You can do a kill all of sudo su, and it would kill every single one. But saying that, now let's take a look at how we can scan for processes. Well, since we have sudo su here, and this is where I'm going to digress from the book, I don't really want to run MSF console right now. We can actually just do it this way. So let me clear my screen, and we can do a PSAUX, but then what we do is we pipe or send that right to grep, and we're going to look for sudo su. Actually, let's put that in quotes so that it does it exactly. Now, what that is going to do is that is going to run the PSAUX command, and then it's going to give us every variation of sudo su, or every instance of sudo su that is there, on top of the grep command that we just ran. That's very important, because some people will see this and be like, oh, sudo su, and not pay attention that it's grep. And that all the options are there. When you run a command and it's in your process tree, it shows you every option with that command. So grep is running -- color equals auto, and then sudo su. So that's how you see that process. Now, what if we wanted to see what processes were using up a lot of our memory and CPU usage? Well, that comes down to a command called top. So if you issue top, you're going to get this screen, and I can make it bigger, but we're just going to leave it as is. And you can see that it sorts by memory and CPU percentage. So this XOR command is actually taking up the most CPU and memory on my virtual machine, which is fine. You need that. All right. But if I were to run a different process like MSF console or Nmap or I don't know, name it, right? LeafPad, VI, if any of those were running, you would see those show up here. And because of how little of my CPU and memory is being used, anything that's going to use CPU and memory is going to eventually show up. And keep in mind, the reason why this is switching is because it refreshes every so many seconds. I want to say 3 seconds, but I could be wrong on that one. So that's why it's constantly moving around, because it's every time it refreshes, you have a different program, or a different process rather, utilizing CPU and memory at a higher rate. So that's top, and that's how you see all that information. Q gets you out, and then we clear our screen. So now that's top. Now what if we wanted to manage these, right? So I told you that everything's a process. And when you're working in Linux administration, or if you're working on becoming a hacker or whatever the case may be, then you have to know how to manipulate processes, because some processes that you are running will take up more resources than others, because they're going to, this is just the way they are, right? They're going to require it in order to function not only just properly, but efficiently. So if you tell something that, hey, you can have whatever resources, kind of sift it between it, everything's default, then it'll get it as it needs it. But, excuse me, what if we wanted to dictate the resources that a process was allowed, or the rate at which a process could accumulate resources? So that is when you talk about the nice command. And what the nice command is it allows the process or program to know how nice it needs to be to other processes and programs in the process tree. So the highest priority processes utilize a -20 on the nice scale. The lowest priority processes have a +19. So what if, and this is why I have so many tabs open so I can show you this, what if we wanted to start a process, and we will say MSF console, but we wanted to speed up any completion that it gets. So we wanted it to increment its priority and take on more resources as required ahead of other processes. So let's say we're running MSF console, Nmap, and maybe some other things, right? We're running WP scan, or something along those lines. Say we're doing all these things at once. We want MSF console to finish first, or at least have the ability to finish as quickly as possible. Well, then you start that with the nice command. So we would say nice-n, and we're going to say -10. So every so many seconds, it's going to increase, or rather decrease, its nice value -10, so that it could take on more resources. And eventually it'll get to -20, and it'll be, it'll be in line with all the other processes, system processes that have the same value of a -20. So we'd say MSF console. So you let that start, and as that's starting, what we're going to do here is we're going to go over, and we're going to go to top here. So as this refreshes, you'll see Ruby. Ruby is because of how MSF console runs, all it is a Ruby command, or a Ruby script. So it's Ruby bin or user bin MSF console, I forget exactly where, but you're looking for Ruby. So we see here that, or we did see it, we can see the nice number is -10 right there, right? So its priority is 10, but the nice value is -10. So every so often that priority will decrease again, or increase rather, depending on how you want to think about it. And it will raise. So the higher it goes up, the higher priority it has, so on and so forth. So that'll start that in that way. But what if we wanted to give a process less priority? So we wanted it to do its job, but we don't want it to be greedy. We don't want it to utilize all the resources. Well, at that point, we exit out of that, and let's clear. Then what you would do is you would do nice-n. Instead of a -10, you would do a +10. And then we would do MSF console again. So as that's starting, let's wait for Ruby to show up. And we see it right here. Ruby, 10. It went away. All right. So that will increase the nice value. So that's how you dictate whether or not you want to use, allow those increases. But now I got another question. What if we wanted to just set the nice value? We didn't want it to increase or decrease the priority. We legitimately just wanted to set what the value is. Well, that's a command called renice. And I could, put it in there or in as a command, but since we're in top, we're just gonna bypass the command because the command is legitimately renice what value you want in the PID. We're gonna make this a little shorter and we're just gonna do it this way. So if I do R, PID to renice. Well, I didn't get my PID for it. So PS AUX grep MSF console. And we're looking for 457208. So we're gonna come over here and we're gonna say 457208. And what do we want to set that to? Well, let's set it to 19. Now, as this refreshes, and I shouldn't be sorting, so it should show up. Actually, let's just do it this way. Let's do quit, top, that way I know it's right. XOR, where's Ruby, where'd you go? Where'd you go, Ruby? Ruby. I know I set you, and I know you're using processes. Where did you go? And I think I set it too low. It's not showing. Alright, let's do this. Yeah, 5.8, 11.9. So CPU percentage went down. 457208. Why is Ruby not showing in top? Because you are using, there it is. 0.3, 11.9, and there's the 19. There's the nice value we set. Sorry, it took a little bit longer. But that is how you would set that nice value. And we quit. Clear. And just to be sure, grep MSF console. Cool. Alright, it's dead. Now let's talk a little bit. So we talked about top. We talked about managing processes. Let's talk a little bit about killing processes. So let's say, for instance, we did have MSF console up. So we're going to let that start again. And while that's starting, we're going to clear. What we want to do is we want to do PS AUX grep MSF console. That way we can see it, because we're going to need that PID for what we're going to look into. This 458018. So there are several different kill signals, 5 to be exact, that you can send to Linux. You have the hang up signal, which is 1, so sig hub, SIGHUP, and that stops and restarts the process with the exact same PID, exact same. So if we wanted to do that, we could do kill-1 458018. And then if we do clear, actually, we don't need to do that. We'll just do, all right, so we're waiting for that to restart. Hang up. It was supposed to restart. I love when it doesn't work. Stops and restarts the process with the same PID. And it did not restart it for me. Bastards. Alright. So it didn't want to restart. Alright. Anyways, there are certain processes that will restart. Apparently that isn't one of them. It's unfortunate. But let's do it this way. Since that didn't want to restart, Let's do leaf pad. Let's pull that up. Let's see what happens if I do it again. Instead of console, let's look for leaf pad, and let's see if this will restart for us. Kill 458527. Nope. Nope. Hang up. Alright, so the book is wrong, so let's figure out why. Mine as well. Linux kill command. Let's do a little search right here. Yeah, we can kill all. We know that. Options. 1. Reload a process. See, everything is saying this one is reload a process. And I can zoom in for you here real quick. 1. Reload. Why is my process not reloading? I don't know. But alright, so I wasn't wrong. It is what it's supposed to do. Why it didn't work, I don't know. But that's what it's supposed to do. Now, let's talk about the other ones. So there's also 2, which is a weak kill. It's not guaranteed to work. It kind of says, hey, if you want to, can you please die? There's 3, which is a core dump. So what that's going to do, and it's everything that it does is outside of the scope of the book, but essentially what that does is it takes everything that is going on with that program right now, dumps it in the memory, and then kills the program and takes everything that was in memory and brings it to a file named core of whatever your working directory is. There is 15, which is a termination signal, and that's the default kill command. So if you just do kill this process, it's going to send a 15 and tell it to terminate. And then there's the final one, the one that I tend to use a lot, just because I only ever kill something through process manager if it is frozen or if it's just not working. And that's the -9. The -9 is an absolute kill, and it basically sends that process to /dev/null, which as we get into things a little bit more, we may see where you can send your error outputs to dev null, and essentially it sends it into the ether and it kills that process. So those are the ones. So if we were to, let's do leaf pad again, and we'll see a different error. So let's pull that up. Well, not error, but kill -9. Well, let's pull up I need this. Let's do that, and then let's do kill -9 459493. Get rid of that, and then we see killed. So this hang up, that -1 is supposed to restart the process. I don't know if things have changed. Please leave it in the comments if you know why neither of those processes restarted. But -9 is always kill. It completely terminates the program and just drops it. It's the equivalent of Windows, where if you say end process immediately, same thing. So another thing we want to look at, and another thing that works great and is necessary as you're dealing at whether you're doing Linux admin or hacker or whatever you're trying to do, is running files or running programs or processes in the background. Now you can background processes and start processes in the background very easily. So we're going to cover 2 options here. So if we say we want to just run leaf pad and we hit enter, we see it here, and now everything, if I make certain changes, you'll end up seeing kind of like a trace of the log or what's going on here. Not always. Some programs will show it, some won't. This one doesn't seem to do it, which is fine. But what if we wanted to background that process so I have access to it, to the terminal again? Well, let's do a PS, and then let's do BG, which is background, 459818, and hit enter. BG 459818, job not found. What? Interesting. Let's just run PSOX, and we should see it. How is that job not found? 459818. BG 459818. Interesting. Alright, let's try to do it with a file. Maybe that'll work. No, don't save no changes. Let's see what files we have in here. Alright, so let's do leaf pad, cyberwarrior. Alright, so we have that. And as we can see here, it's still running. We can't use this terminal screen. So that's kind of like what I was talking about. But you should be able to background it. BG 0168. Doesn't like it. All right, you're supposed to be able to background that process. Why it's not working, I don't know. It works with other commands, so maybe it depends on what process you're using or program. But yes, BG does work. It's just not for LeafPad apparently. Which again, like I said, is fine because we're going to show you how to start a process while running it and giving you your terminal screen back. So if we do LeafPad cyberwarrior and then we put that ampersand at the end, whoops, not there. We put it there. We hit enter. We get our screen. Right, so we can now still use this terminal. We get told what the PID is, what the process ID is, and then we still have access to our screen. No big deal. So now what happens if I just want to see if this would work? 460.415. No, it's still saying not there. So I guess we have to be doing a certain types of processes. Could be foreground and background. LeafPad must not be one of them. Which again, it's fine. It happens. Some applications aren't designed that way. I was hoping this one was, but I guess not. But at least you get to see what the commands are. They just don't always work for what I'm trying to do. But it's okay. Because even in the book, they don't really show you it working. They just tell you, hey, this is a rogue process or something along those lines. So the other way we could do this, and you can see it work. If we open that, so there is another kill command that I neglected, so let's talk about that real quick, and it's called kill all. Kill all -9 LeafPad, and we hit enter. And what that kill all does is anything with that name, LeafPad, it'll close. Anything. So that's that. So the next thing we want to look at is the at command. So what the at command does, it says at a certain time, run this process. So if we were to say at 5:30 p.m. and hit enter, I don't have it installed on here by default. You gotta love it. So we're gonna install that real quick. Give it 2 seconds. So let's see. So now let's try it. Oops. Hey. So if we use at, and it'll say, hey, at, what do you want to do? So at 5:30 p.m., what command do we want to run? Well, we want to run LeafPad. And then we hit enter and control D. So now at 5:30 p.m., LeafPad will run. And you can also do it, you could set full dates. You could say, hey, at this exact day and time, run this command. And why does that matter for hackers? Well, because it's kind of like a cron job, right? So as soon as you want to schedule a process, and maybe you want to put it on a delay, then that's what this would be used for. Or hey, say you have you're at work and you're a Linux admin and there's something you need to do. You can use this and actually kick off any scripts or anything you want to do at the exact time you want to do it. And this will put it in the system, execute it with binsh, and you're good to go. So just be aware of that command. But saying that, look, hey, it's been a blast. This is chapter 6, I believe. 6? Yeah, chapter 6. And next week we're getting into our environment variables. So remember, Linux Basics for Hackers. I hope you keep following along. I really do. Leave any comments you have down below. Make sure you like this video. Subscribe if you haven't done so yet. And hopefully I see you all next week. And hopefully, even more so, I see you on Fridays for Security Happy Hour, because we're live there every day, every Friday at 7 p.m. Eastern Time. And hey, merch links in bio.